Good evening again, everyone. My name is Melissa Raspberry, and I am super excited to be here tonight as the tech support for this wonderful webinar with the CS4L teachers community. We have a terrific set of guests to talk with you about the Create Performance task and understanding algorithms and abstractions. Deepa, Jill, Chinma, and Fred are amazing computer science teachers, and I know that you'll have lots of rich conversations with them. Before we begin with the content, I just want to send another reminder and put a plug out there to please ask you to mute your lines on your phones or with your microphones. You may not realize, but there is some background noise that happens, and we want to try to minimize that as much as possible. So either directly on your phone, you can hit the mute button. You can also use *6 to mute on your phone, and then #6 to unmute. And then there's another option that at the top of your screen, if you're just connected via your microphone through your computer, you should see a drop-down option with a little phone or microphone icon and then a little arrow beside it that creates that drop-down menu. We do hope that you will ask questions, share your ideas, etc. as we go on. Because we want this to make it as participatory as possible, but just ask that you please mute yourself in the process. And so hopefully I won't have to mute too many of you. I'll hope to unmute as needed, but please do help with that so we can cut down on that background noise. But with that said, I'll go ahead and turn things over to Deepa, who will take things from here. Thanks, Deepa.
Hello, everybody. This is Deepa Muralidhar here. Good evening. Welcome. I'm so happy to have all of you this evening. We have a very interesting topic and a very useful topic and perfect timing for it just a couple of months before the actual AP exam. Very, very excited to be able to introduce our guests. As Melissa mentioned, we have a very unique combination in that we have all high school teachers. All more power to our high school teachers to just convey exactly what our experiences are. And every one of the panelists in today's webinar are not only teachers, they are leaders, they are presenters, designers, curriculum developers, and readers. So they grade, they help students, they help teachers. So lots of conversation, and definitely hope to have many, many of your questions answered. First, I'd like to introduce Jill Westerlund. Jill Westerlund is a teacher high school teacher in Hoover High School, teaching APCS principles, APCSA, and IB Computer Science SL. She was one of the national pilots for the APCS principles course, and currently is part of the Instructional Design Committee and is a CollegeBoard consultant. She participated in the first AP CS Principles reading in 2017 when she was the table leader, and this year she is the chief reader assistant for the 2018 APCS Principles exam. Jill, welcome. I know that you go around the country training teachers almost every Saturday, and very, very active as both on Facebook as well as through your Abstracting CS blog. Tell us about your opinion on how students view algorithms and how you guide students and teachers to work with algorithms.
Thank you, Deepa. Hello, everybody. I actually sort of do that Stephen Covey begin with the end in mind and ask students to think about the algorithms they want to create first and then think about the projects that they would like to make. So we sort of begin with the diagramming idea. That seems to help people not just jump off a cliff and start making something fun and then try to retrofit, math into them or loops into that. So that's a little bit of my style.
Great. Thank you, Jill. I know that it is one of the most hardest pieces for the students when they understand what's an algorithm, but when you're asking them to identify an algorithm, they're like, Ms. Deepa, what should I look for? So your tips are very, very handy, and thank you so much for them. Next online, we have Chinma Uche. Literally, there is no one in the computer science education community who doesn't know Chinma. Chinma is a high school teacher at the Craig Academy of Aerospace and Engineering in Connecticut. She's a PhD in biomathematics from London. She was a national pilot for APCS principles and a co-PI for the mobile CSP curriculum. She worked with Raf Morelli to create the mobile CSP curriculum and currently serves as the APCS Principal Development Committee member for CollegeBoard. Welcome, Chinma. We are absolutely very happy to have you here. Do you want to share your thoughts with us about pacing and how teachers probably should try and structure the create tasks timing-wise, or when should they do it, and how should they go about working with their students? Hello.
Sorry, I was speaking with the pen muted. I'm sorry about it. I just said good evening, everyone, and thank you for being here. I just hope we'll be able to share ideas that will help you in your classroom, and from you also learn something that we can use ourselves. In terms of the CS Principles course, I look at the performance task as a real, true course assessment. It's something you introduce to students from day one, so you start using those keywords they need. However, as you get closer to the end, it's important to plan your course and pace them, because the CollegeBoard requires 8 hours for the explore task and 12 hours for the create task. And this is something that will take you virtually more than a month of time. So if it's not well planned, you'll find yourself running into trouble towards the end. And what happens is at times when teachers haven't started the performance task, they get under pressure. How am I going to finish this? What am I going to do? My advice would be, if you're wherever you are, I'm expecting that most of you would have done the explore task by now or the create task, and at least have one done. But if you haven't, it's still important that you keep calm, because if you're not calm, your pressure will translate to your students, and your students will feel it. So wherever you are, try to see how you can organize the remaining time to make sure that you get all of them in. Because the 8 hours is a minimum requirement for explore, and 12 hours is a minimum requirement for create. However, it's really important to, wherever you are, be calm and see what you can do, or whatever you do. But when you teach it next year, because we get better as teachers as we do our job. So where you do it next year, it's always good to plan some time and at least start one of the tasks by February, so that by March you'll be sure you'll be able to finish all of it and get it in on the time. Deadline for submission is April 30th. So you want to make sure that your students submit. There have been cases where people completed the project and the students didn't submit it in time. So you wouldn't want that to happen to you after 1 year of work. Thank you for being here. Just hope we'll continue to share ideas.
Great. Thank you so much, Chinma. And last but not the least, we have Fred Major. Fred Major is a high school teacher teaching AP Stat and APCS principles at Brook High School. He has a master's in education in mathematics and BS in economics. He was an AP reader for the APCS Principles 2018 and a pilot for the CS4 Alabama APCS Principles pilot. Fred, welcome. One of the things that you and I had talked about is when we discussed this webinar was the challenges that students had trying to understand what incremental and iterative development cycle meant to the students. And honestly, you're so right. I would say the single biggest question as my students implement the create task, they just started the create task, the AP's create task today. And as we did the practice over the last couple of weeks, the one question that was asked again and again was, what was the difference between incremental and iterative? Would you want to talk a little bit about that?
Yes. Thank you, Deepa, for having me tonight. And we talked about that question. I think when they reorganized the rubric this year, the one thing that, well, one of the things that jumped out at me, and to me it's one of the most sneaky points on the rubric, is the second row, which wrote response 2B, is rows 2 and 3. And the third row students seem to understand really well, because it says, identify at least 2 points and difficulties and how you overcame it. And when you read the directions, where it says describe the incremental and iterative development process, then the next line, the directions go straight into the focusing on 2 distinct points. I think it gets lost by most students, including myself at first. And even if you look on the on AP Central, on the examples that the AP shows, the only one of the out of 7 or 8 of the responses actually gets that point. And they get that point, it's sort of hard to decipher. It's basically one sentence in the response in 2 different places, or parts of 2 different sentences, rather, give them that point. So I really tried to, when I focus on the students, yes, you have to talk about the two distinct points, but try to remember you've got to give the reader some idea of your overall process of how you created your entire program, focusing on, what was the first part of your program you wanted to develop, and then what did you add on to that, and what did you add on to that, and how did you test that in between, and really trying to make sure the students understand you've only got 250 words, so you've got to get all that done in just a few sentences. And I think that's the best way to make them aware of it, that it is a separate part of it, and that response, has to be addressed specifically.
Good point. Very, very good point. And I do agree with you that it is fairly sneaky and has been, with the changes in the rubric, it has suddenly gotten much more importance than it had done in 2017. Very quickly, as we start the webinar and start asking our questions, so we do have someone who says that, our speakers, including me, we need to be just a bit louder, so we will certainly try to do that. The APCS exam basically consists of the performance tasks, the create and the explore, and then the multiple choice. And as I do my second year of implementing this course, I have come to accept and realize that is a lot. All this asks for a very busy year. Keeps us very busy, constantly planning and getting the students ready for this. Do I have the percentages wrong? Again, I had them last year time too. My apologies. It is 16 and 24. At the recap from the previous webinar with the chief reader, things to note about the create task. Don't forget, it now has 8 rows like the explore task, and the rubric is binary. He also recommended that students use the template that CollegeBoard provides, because it just helps with the grading, and it also seems to be that the students and they are more conscious that they need to answer all the prompts and not write an essay. Okay, moving on. The first question I had was, what's an algorithm, and how do we define an algorithm? What would be like a CollegeBoard definition of an algorithm? What should a student pay attention to if they were to select an algorithm in a program? Jill, would you like to start the conversation on that?
Sure, Chinma. Deepa. Okay, so the way that I teach algorithms is to ensure that students know that there are 3 types of algorithms. Fundamentally, everything's going to fit into either a sequencing algorithm, a selection algorithm, or an iterative algorithm. And so I sort of began that earlier in the year, but, we're to this point in the year. So I would start with that and have students begin to understand that any type of, if statement, while statement, for loop, is going to fit into one of those things. And if it's not one, it's going to be another. That's important. I think that students also, for the purposes of the create task, need to really understand how to use math and or logic as a part of an algorithm. One of them must have math or logic. I think, in my room I try to ask them, let's just go ahead and have math or logic in all three, if possible, so that, we can, shoot for the moon and then you hit the stars regardless. So those are two things that I think are critical in terms of what students need to pay attention to while they are planning their algorithms. And I would also say that when they're selecting the algorithms they want to describe, they need to select the whole algorithm. They don't need to just select the if section. They need to pick up the whole if-else section. And if there's nesting going on, they probably need to show the whole entire thing. If they want to discuss the section that's nested, then that's fine. Maybe that's where they need to draw their oval or use some computing tool to draw attention to that portion. But I would say that two things are important. They need to be able to explain the type of algorithm it is, what it's doing in their program, and then explain the math or logic. A combination of all those three needs to be a part of what they need to describe in their written response, because the points are going to get awarded based on what the student explains, not the algorithm itself. They can have a gorgeous algorithm, but if they can't explain it in their written response, they're not going to be able to get the points. So I think all of those are important items. Maybe Fred may have his, comments to add to that, or you may have, Deepa.
Good. Thoughts?
I think one of the things that struck me, what Jill said, as a reader last year, I saw some just absolutely beautiful code, in Python and in Java. Just, the students had obviously had plenty of knowledge, but then they either didn't write effectively or didn't follow the prompts about describing, what the algorithm, the two independent sub-algorithms did and how they worked together to get the top algorithm. And so they got no points. And then I saw, some very well done, but, much simpler, block language programs where the student wrote very eloquently and explained exactly what, the first algorithm does this, the second algorithm does the second. They work together, accomplish this third goal, and that got full credit. And that really, I've tried to explain, bring that home to my students too, is that it can be the best algorithm and the most complicated algorithm that's ever been written, but if you can't explain it, you're not going to get any points on that.
That's exactly right.
And definitely, just to highlight, the entire thing that's being used needs to be put an oval around it. Everything that is part of the algorithm they're discussing has to be circled around. Question two, my bad, I haven't moved it, I apologize. I was so focused on the question. What advice can you give students on how to write and reflect on the algorithms? Now that you have said that it doesn't matter how gorgeous the algorithm is, it all depends on how well they are described. Advice, Chinma, can we start with you? What advice can you give students on how to write and reflect on algorithms so that they can score well?
I think also based on what Jill and Fred said are really good. What's important is that your kids also know the distinction between an algorithm and an abstraction, because students get to a level where they mix up things. So they won't identify what they've done well. So identifying it and being able to talk about it. So like you have already said, the need to use the templates would help them know which one they're answering. But then knowing what an algorithm is, knowing the different parts of the algorithm, identifying it, why this algorithm, why have I chosen it, what are the properties of the algorithm that makes it fit what the College Board is asking for. The template would help them a lot. Like Jill talked about the mathematical and logical, they need to be able to show where it is and then be able to get their point. What's an algorithm that's using another algorithm? those distinctions. I think it's important for us as teachers to make sure that teachers students the word algorithm and abstraction both start with A. So there is always that confusion. Being able to know which one they're talking about I think it's not a powerful test. And if they know an algorithm as the sequence of steps to complete a task or to solve a problem, then they need to be able to say the whole code is not an algorithm. The whole code they need to figure out which part. And I think those are the things we are looking for during grading. You identify what you're talking about? How is it the algorithm? What does it do? A sequence of steps to accomplish a task. An algorithm is not one line. An algorithm is not a statement. It has to be more than one statement grouped together to solve a problem. You have to define what that problem is. I am selecting this algorithm because to solve this problem. And then you're able to show that where the math and logic is. And so students need to use the rubric. I think for us as teachers, we understand what the rubric is. We need to help our students understand what the rubric is, what it is that's being looked for.
Great. Thanks, Chinma. There are a couple of things that I wanted to make a comment on. There was a question from Alex MacTuga. I'm sorry if I said that wrong. When they say templates, are they referring to those from the survival guide? The templates are on AP Central, as somebody mentioned in the chat window. Code.org created a survival guide that had some materials in there. I do know for a fact that the digital portfolio also has the templates that can be downloaded and has been extensively referred to in the AP discussion forum as well. If you log on to the CS for Teachers, Open CSP group, today I will have the template up for your downloading as well, convenient. So that is how that should also help. Jill, do you want to just take over and maybe mention the piece about the website that you mentioned about it and how that could be used to write and reflect on the algorithm?
Oh, yeah. Well, I did want to say, too, is you don't have to use the template. You can just have the students use a, 2-column, 5-row table in Google Docs or Word to type up their responses. I mean, a grid is helpful, but don't get panicked over the template if your students haven't used it. My students don't use the template, but that's just because I'm sort of a control freak. So anyway, I didn't want people to panic over a template. But there's nothing wrong with the template. It's just personal choice in your classroom with your students and yourself. So I linked in the little website for this little interactive quiz from 101computing.net. It was helpful in my room for students just to run through it. I think it's 10 questions, and for the most part, they're going to probably get 8 or 9 of them correct with almost no background. It just kind of gives them an idea of how they, how you can say, this is a for loop, which category would I put that in? And this isn't necessary, but I think it shows depth of understanding when a student can say, here is my algorithm, and it is a sequencing algorithm because it has 10 different program, statements that work together to perform a mathematical calculation or to reset the timer and reset this and move the player from one section to another. So I think it shows depth of understanding. It's certainly a scoreable item, but I believe it's useful. The scoreable item that students need to pay attention to in terms of their algorithms is explaining the math that is happening and explaining what is going on in the larger program that this algorithm is doing the work for. What work is being handled by this algorithm? So I think that's the meat of it. To get row 5 on the rubric, you have to have math or logic in your algorithm. And then to get row 6, I'm going to make sure I'm saying the right row numbers, but I think I am. Yeah, to get row 6 is where you have to have 3 algorithms. And, of course, one of them must have math or logic, but the 3 algorithms have to work together as a happy little package. So this is really, in my opinion, if you haven't begun the task with your classes, this is where I begin in my room. I have students figure out what kind of program they can build that has 3 things happening in tandem and in nicely. So that's what I'll do. And then Chinma, I'll let you pick up from here.
Yeah, when I was talking about a template, I wasn't talking about any material produced by anybody. If you look at the digital portfolio submission site, there are spaces for students to put in first. So that's the template I was talking about. Like if you're answering 2A, where does it go? 2B, where does it go? That's what I mean by template. Those things are supposed to help the students make sure they're answering the correct question. So if you show them the questions and possibly lead them through the digital portfolio submission site, you would see what's required. And that would make sense. So there's no special thing. It's something everybody has access to. That's what I was talking about when I was using the word template. So like if it's in the flow, you think A, 2B, 2C, 2, that's so let the students make sure that their answer for algorithm fits into the box for algorithm and talks about algorithm the way it's required there. So what I usually do is like I go through the outside going through the what's required, I also go through what they need to submit and the different sections. We have a practice task we use to lead them through it so they understand what should fit into each box, and then they can do it. So I was using the template as a general word. So I hope I didn't confuse anybody.
Oh, no, Chinma, that was perfectly fine. Moving on to the next question while we have the mic mic with you. Could you talk about abstraction, what is an abstraction, what programming constructs would count as an abstraction, your experiences on those? Chinma?
Yeah, for abstraction is, like we said, what we have said, all of us have said, these are things you introduce gradually. The people who will introduce it gradually, I find students mix up words. So you need to find a way to make it real to them. So I usually start with different picture or different levels of clarity and say which one is a more abstract picture. So I want them to use something they know already and relate to it. But effectively, abstraction is about generalization or hiding details, depending on how you're using it. So you're looking at a concept and you're saying, oh, I can draw a circle of radius 2, draw a circle of radius 2, draw a circle of radius 5. But then if you use a variable, which would be your first generalization of the concept of drawing the circle, you help them see they can do more. Then it is a drawing, using a variable as an abstraction is really one of the lowest levels of abstraction you can use. The College Board wants the students, by the time they finish a year of computer science, to know a lot more than use of variables. So it leads on to write, in some languages, what's called functions. In other languages, what's called procedures. The students are expected to write a procedure. And the whole idea is for something that reduces complexity and makes sense and generalizes concepts. So they have to show that they understand what it means to generalize. What are you generalizing? And so if that concept is clear to them and they understand why I need to group things together and then generalize it, so they can do what we call data abstraction, which will be using something like list or an array or whatever, depending on the language, to bring together a concept. Instead of doing it for variable 1, variable 2, variable 3, you then group it together into an array, and an array that captures the essence of whatever it is they want to illustrate. Or they create a function that they can reuse. So that reusability, generalization, these are the concepts that are being tested at the level of getting, this is one of the higher level scoring points for students. There are things students will get easily, but when you're talking about abstraction now and explaining it well, you're looking at a higher level point. So making it clear to students the difference between abstraction and algorithm, and that they have to write their own function, not using constructs that come with their language, but their own, and seeing how it fits into the general problem they are solving. That's an important step.
Cool. Fred, thoughts on yours? What programming constructs? I know that I was reading about it and it said collections. Maybe the language that you choose, what collections do students use that you told them can count? Like in my class, I told them, because we use Python, I told them that they can use lists, and I told them that even a function's parameters that they pass can count as an abstraction. Thoughts on that, on what you gave students?
Yeah, so certainly lists, I think, are on that as part of the collection. Personally, I sort of try to, I thought last year at the reading, the using a list was, I don't want to say dangerous, but I didn't see a lot of good use of lists. So I do have some students. We finished up about 2 weeks ago. I know I have some students who did use lists, and I think use them as their abstraction. This year, with the updated rubric, to me, my favorite part of the rubric that got updated were the last 2 lines and how they deal with abstractions. With my students, whether it be in a block-based, most of my students this year tended to do block-based language for the task, and sort of the word in the room has been, the abstraction is you need to create your own block, or those have chosen to do possibly Python would say, a function. You've got to create your own function that does something, important in your program. What I try to warn students not to do is just, because I have seen this, where they'll just say, well, here, let's just take this. Here's 5 lines of code. Let's just create a block. And while that is certainly, I guess, could be argued as an abstraction, the point I try to make is you need to have, the abstraction needs to have use in the program. Where is something that you're calling a function or a block that you need to execute several times? I think Chinma's example with the circle or a figure. Are you drawing several things? If you are, can you call that block several times? And if you can pass a parameter in through it, even better. And actually, Jill, in a separate conversation a couple of months ago, when I was looking at the rubric, because something that I wanted to point out, if you look at the instructions for the create task, it still has the language about they require a math and or logic, but that is no longer in the rubric. So if you haven't started to create, or if you're in the middle of it and kids start to worry about that math and logic in the abstraction, it's no longer there. It's not going to be graded that way in the rubric. And something that Jill gave me was kids that create games, certain scenarios where the game has to reset itself, or you want to start the game over. That's a function that gets called several times to get everything back to initial conditions, and that's a great place to use an abstraction, because students probably have that already. In a couple of different, however their game restarts, and if you can just make that into a block or function, then to me you've got those 2 points for those 2 lines taken care of, as long as you write about them effectively.
That's true. I want to piggyback. Can I piggyback on Fred?
Go right ahead. Please
Yeah,
go right ahead.
yeah, a reset button or clear all is a great abstraction block because it would definitely manage complexity, and that needs to be a part of what they write up is explaining how their abstraction manages complexity. But I would also say that for a student who has their 3 algorithms in their project, if they make each algorithm into its own block or function, then they could choose one of those blocks to talk about in 2D as their abstraction piece. So they could, I guess, double dip, you might say, by saying in part 2C, they would describe it and explain it as an algorithm and what it's doing algorithmically. But then in 2D, they would discuss the same section of code as an abstraction, that it is its own bundle of code. It manages complexity because it is its own block, its own method, its own function, and explain the same thing 2 different ways. They would, in that case, need to put an oval around it as well as a rectangle, and I would probably use, like shape tools or call out arrows or something to, make sure that the reader sees this is one of my algorithms. Maybe it's algorithm 1 or algorithm 3, and it's also my abstraction piece.
Great. This is probably one of the, it is very true what Fred was saying. I was thinking about it as I went through this, that once you've written an abstraction, they're going to get that point. Then the point is to explain complexity. So in many ways, to what, just emphasizing what Fred was saying, it seemed to me, and I was telling my students, row 7 and row 8 are probably among the easier ones to get after the first 2 points on the purpose and function and getting the video. Moving on to the next question, my internet is being super wonky, so I do think I need somebody to just move my slide to the question 4. Thank you very much, Melissa. What scaffolding activities would you help a student learn to design both good algorithms and good abstractions? Jill, since we have the mic on you, would you tell us something about this? I'm looking, maybe like what would be helpful for teachers to say, that's an exercise that I can try in class, or something that you have used, something that you and Fred have discussed. Thoughts?
Let's see. For good algorithms, for the purposes of scaffolding toward create, I want an algorithm to have an operator in it. I want to see a plus, minus, multiply by, greater than, less than. I know they don't all have to have them in there, but that makes me feel better. And obviously you can use equal to, exactly equal to, and if touching, if color equals this. So I would like something like that. And then for abstractions, you just got to make sure your students know how to build a block or a function or method in whatever programming languages that you're doing. They just cannot use any type of event handler or pre-populated one. So I would take some time and make sure students can visually identify by color. If they're doing a block-based language, you can definitely use color to say, in App Inventor, it's a purple block if you're building your own block, and in Snap it looks a certain way. I'm not as familiar with App Lab, so I don't know if there's a color coding to that one. Somebody can probably comment that in chat. In the function in Python and a method in Java. So any of those, it has to be made by the student. It can't be one of those things like when J key is pressed, do this. That's not going to get them any points at all. So any type of scaffolding activity where they can look at code they've made, look at someone else's code, give them a completed project, and they pull down a completed project and have them put ovals around algorithms and discuss them, and put rectangles around abstractions. And many of us who've been working with the course for a while have got completed projects in a variety of languages. So, reach out to some of us, and, we can probably share a large file that you could, have your students work with in pair programming to do those kinds of things.
That sounds absolutely excellent. Thank you, Jill. Fred, thoughts from your end? And then we'll pass it on to Chinma on the scaffolding. Meanwhile, before I ask Fred, I wanted to bring out a question that was asked here about, can a loop be used as an abstraction, since a loop manages complexity, but it is not student created? And Ian's response was, it had to be student created. Fred, would you take this for us before you answer the scaffolding activity question as well?
Sure. I mean, I think the fact that in any programming language, the loop is going to be provided by the language. I don't know. I guess if we got real theoretical, we could go way far back, and I guess if you turn something into machine language, and wrote a logic gate or something, maybe they could get credit for that. But if they do that, they deserve credit, so I won't go there. But yeah, that was that question. I think when you're looking at a loop, that to me is probably going to funnel more into the algorithm piece, and then using Jill's idea, if you put that algorithm into a function or block, then you do have an abstraction. So I would, the loop itself, and that's where I think students need to be careful about, when they write about it. The loop itself, I don't think would satisfy merely because it has not been student created. But if the loop is inside of an algorithm that accomplishes a task that is then inside of a block or function, then I think it does get credit.
That sounds excellent. And thoughts on scaffolding activities?
So probably the most important thing, and I'd like to tell you I did a great job at this year, because I had this thought last year at the reading and I did not, but I've got it in my notes to try again next year, is from pretty early in the fall. I like to start coding either on the first or second day of class. We have sort of a weird first day schedule, and sometimes we have really short classes. But by the second day, I like to, because that's why the students are in the class, even though there's other stuff we need to talk about. They want to get their hands on a computer. And so pretty early on, we had that discussion, like to have that discussion about what an algorithm is, especially abstraction maybe a little bit later. But through the course of the year, as they're doing other projects, go ahead and have them identify an algorithm and write what it does. It doesn't have to be, I would say, definitely scaffold up to work, the two working together as the third. That's, you don't want to start there, but what algorithm did you write? What does it do? And that's really easy in the beginning of the year, if you have a very simple task about drawing a shape or doing some kind of geometric formula. I think that's pretty easy. This year, Jill mentioned, looking at other student work. Don't forget, if you go to, AP Central and find the homepage for Computer Science Principles, there is, I really cannot remember, I'm not looking at it. I think it goes to like J, different examples of student work. And so this year, before we use Canvas as our course management system, and we created a link to I picked out 3 different tasks. One we sort of looked at and graded together, and in Canvas I made a Canvas quiz where they graded that task, and we all did one together. And then in groups, I think of 2, I gave them 2 other ones. And I did not, one we did in class, missed a couple, this whole class. One of the ones that we did all together was the only one I think that got all points. And then another one I did that only got about half the points, just to give them different ones. And I did try to go back. So if you want to make yours look like one, you want to make yours look like the one, or not look like, but if you're going to model one, you want to model the one that got all the credit. And then I also have another teacher in our school also teaches computer science principles, and she had this idea that sort of we got from. Well, I'm blanking how we got the idea from, but during 15 days is a long, or 12 hours at our school turns into almost exactly 15 days, and that's a long block of time. And so we try to break it up and do other activities. And one of the things that we did is after a lot of the students you felt like they were finished coding and starting to think about writing, but not quite there, is we just stopped one day, and she had written a SNAP program that you asked for a couple of inputs, and then it was how long it calculated and did a few graphics about how long it would take for a zombie apocalypse to occur. It's basically just exponential growth. You could do it with bacteria or whatever, but it was a lot more fun with zombies. And she wrote it up. Well, actually, she didn't write up the response. We then said, okay, let's, as a class, or in pairs rather, identify what could we use to satisfy the algorithm requirement, and where could she use to satisfy we did both 2C and 2D, algorithm and abstraction, and then wrote responses, and then would switch and grade the response. So they, hopefully through the course of a year, you scaffold up to that point, doing it themselves, and then flip the switch to actually think about how a grader would look at it, and go ahead and practice writing it up.
That sounds outstanding. Any other questions from the group that we have not yet heard from? I think we've tried to respond to all the questions out there, but anything else from the audience that you would like to ask in the chat window or do a mic?
Okay, while they start to write their...
Donna's got a great question. Deepa.
But Jill, do you want to?
Yeah. So Donna's question is, when students are creating video for the task, do they upload the MP4 or do they post a link? We're not allowed at the reading to follow links to external sources. So it's imperative. It's imperative. They have to upload a video in one of the formats that CollegeBoard has outlined. So if they don't upload a video, it would, there would be no point for whatever row that is, one or two or both of those rows. I think it's just row one that's the video. But so yes, they do have to turn in a video file because the readers are not allowed to follow links to external sources to score work.
And Jill sort of mentioned it. When you go to upload the CollegeBoard systems, if the video is 1 second too long, 0.1 megabytes too big, or the wrong format, it won't accept it. And I use that. So when that has happened last year and this year to a student, and I stopped the whole class at that point. We have a little mini lesson on metadata, and how does the system know that file is too long or the wrong format? And so just a good teaching moment, and to remind them you got to follow the rules, or you can't get it in.
Right. And then VJ Cherie is asking about citing images. I would say in terms of citing the images, I would do one of two things. I would probably tell students to cite the image in their code, do a code comment, either right-click if you're in a block language and add a comment to your code and add your source there, or, if it's text-based something, and that's how their code's going to look, I would comment it that way. They also could cite their source in probably their 2B section where they describe their iterative and incremental process, and at the end of that, maybe add citations. I probably wouldn't put it there just because that's going to add words to their word count. So I'm thinking probably comment the code with their sources. I don't think we're checking for that. It's not on the rubric, so that's probably outside the bounds of what's going to be looked at. But code from outside sources is supposed to be commented in their code, cite external code sources. So I'm thinking, I feel good about saying it. Comment their citations in the code.
Great. Thank you, Jill. There was a question on should they turn in the entire PDF of the entire code or just the snippets of the algorithms and abstractions? And it's actually the answer is both. You have to submit the entire PDF of the code and then the snippets of the algorithm or the abstraction along with the reflection. Chinma, would you like to expand on that? Anything that you might have thought about?
Yeah, students are expected to, like Jill said, circle and box sections, but the whole code needs to be submitted. They can indicate the algorithm somewhere in the whole code, but that doesn't stop them from submitting. So there's a section for uploading the whole code. So they need to be able to upload it so we can see how they fit into the overall structure. I wanted to talk about scaffolding activities, the way I do it. I start, like Fred said, from the beginning to talk about algorithms and abstraction. And the example I use in my class is usually we start with a fun activity, which is the code.org, the hour of code, the maze puzzle, Angry Bird that kids are used to. They must have done it under the hour of code activity. So what I do is I give it to students as the first when they do a class. They have fun, and after all the fun, then the question is, how is it that this block that's called move forward is able to make an angry bird move from this point to this point? And as we discussed that, they understand that there's code hidden behind it that's making it do move. And that's how I introduce the concept of abstraction. So it's capturing code that we don't see, it's hiding some material, it is important, it's a part, so I introduce that. So I can talk about an algorithm that makes the angry bird move 3 steps forward. And then the abstraction in that block. That particular block is provided by code.org or by Blockly. As I tell them from then, you're going to create your own block. And I like what Fred said about talking about the colors. Like in Art in Pencil, which is what I use, the block is purple. So if you're creating an abstraction of your own and you haven't made the procedure, then you are not meeting the direction. So if we continue to ask them, and there was something else I liked Fred said, it was about asking them to show, always giving them code. Use the samples on the CollegeBoard website and go through it. Help them identify where the abstraction is, where the algorithm is. So when they are writing their own, they know what they are looking for, what they need to include, and how it's going to be useful for them.
Great. Thanks, Chinma. The last question, kind of reserve the last one for the big one for the end. Jill, can we start with you, ma'am? What role may collaboration play in the CREATE task? The AP CREATE tasks is very unique in that it does allow students to work together. So what does allow? Where does collaboration, it stop being collaboration and become plagiarism? So Jill, could you start with you, and then maybe Chinma and then Fred can finish off with this? And we do want to have thoughts from the audience as well.
Okay, so I'm going to start with the official answer, and then I'm going to tell you how it comes to life in my room. The official answer is, according to the CollegeBoard guidelines for students about their task, students may not collaborate on the video or any of the written responses. Student work that has been revised, amended, or corrected by another individual, with exception of cited program code. Students may not submit work that's been turned in class and that they've gotten feedback on. So that's how it is worded. In my room, this is an individual project because I think that we want a small-scale project that has the 3 algorithms that we need in the abstraction element. And so to build the scope of project you would have to build to have 6 algorithms and all of these other moving parts so that 2 students could somehow subdivide that and write up separately about it, I think is beyond the scope of 12 hours. So everybody works on their own project, and the only thing they can collaborate on in my room is they can troubleshoot for each other. A part of their development process really needs to be that someone else uses their project. You know, someone else tries their app, someone else plays their game, someone else uses their restaurant calculator or whatever it is that they've built. Somebody else uses it as a user and gives them feedback. And that's a part of what they would explain in their development process to be. So in my room, and according to how I feel like this functions best, is for students to use each other as peer feedback. They certainly could troubleshoot. I think they could, you know, someone understands how to do lists better. Someone understands an API element better than someone else. I think they can interact when they're creating their code, but then it has to come to a screeching halt, and they have to do their videos separately, and they have to do their write-up separately. And so it's difficult to manage that. So for us, I just boiled it down to everybody's going to design and do their own project independently and by yourself, but you do need to work through the development process together. So I hope that makes sense. If it doesn't, please write in the chat. But I read you the wording from the student guidelines, and then, you know, so, and I see Alex is saying if some of them are doing the same things. I don't think it matters if 2 people are doing the same project topic. There might be 2 students in my room that both made a how to compute slope or how to do, you know, the tip at a restaurant or something. As long as they're not working together, one person might be doing it in Python, another one might be doing it in, you know, Java or Snap or some other language. So I'm not as worried about topic as I am 2 people trying to subdivide the same project. That makes me really nervous because I think in their write-up they might talk about we did this and we did that, and it's not a we project. So that's going to get you way off into a slippery slope in trying to get your project scored. They can help each other with their code. So they can collaborate in their coding portion. And if someone else does have code, or if they use code from, say, Stack Overflow, they need to cite that in their code. That's another reason why they turn in all of their code as a separate document. Anything they use from a website or an API or anything like that, or another student in the class, they need to cite that.
Great. Thanks, Jill. Fred, your thoughts, and you also had a response for Donna, so go ahead, please.
Yeah, I think it was Diana asked, you know, are the students awarded a point for, I don't remember if it's response 3, the number 3 you turn in a PDF of all your code. The answer is no, that's not addressed on the rubric. As a reader, that's, I don't really want to tell the students this, but that's sort of a last resort. Hopefully the reader will not have to look at your code if you've done everything right. But if there's a question about your code, if something you refer to doesn't quite make sense, then the reader would go down to your code. That's usually a sign things aren't going very well. But it is a requirement, and you know, it's just that one last thing you want to make sure you get it done, because it could, you know, save you a point somewhere else. I don't really want to say much about the collaboration because I agree with Jill. The first year when I was a pilot, I tried to do sort of the partner projects, and it just ended up where they did one project, and it was not individual at all. As a reader, as Jill said, you see lots of we statements, and students stop earning points. So I did, if you look in the document Jill was talking about, somewhere above or below what she just read, there's two pictures about these ideas the College Board has had for ways to collaborate, and one of them shows two separate ideas, and the students just help each other by, running the code, troubleshooting, and that's the setup I go for in my class, is that I want you to have a partner and have somebody to talk to and collaborate with, but your programs need to be completely different.
Thanks, Fred. There is one question from JP. JP, did you want to take the mic and ask it again? We are close to finishing up, but did you want to ask the question and unmute yourself on that so that we make sure we answer your question correctly? Okay, so JP says he doesn't have audio. Let me try and make sure and he's not able to unmute. Can students get help with the algorithm and abstract code, perhaps in debugging it? Jill, your thoughts on this, ma'am? And we are running out of time, so after Jill answers this question, I am going to go ahead and hand over the mic to Melissa and thank Melissa AIR for all your support of the computer science education community.
Yeah,
Jill, do you want to just finish that up?
Yeah, I agree. They can definitely debug for each other, troubleshoot for each other, improve, all of that together. The abstraction and the algorithms have to be written by the student whose project it is. But in terms of that development process, I think it's definitely richer if it's done in a collaborative way. Yes.
But the algorithm piece and the abstraction piece have to be independent. These developed.
Right.
Right.
Correct.
Okay. Great. So thank you very much, Jill, Chinma, Fred. This has been an outstanding webinar. Yes, Jody. The template is located in the digital portfolio, and thank you very much, everybody. Melissa, again, I can't thank Melissa Raspberry enough for all the support that she has provided. We would not be having this if it were not for her vision and her experience. And I would like to hand the mic over to Melissa at this point.
Thank you so much, Deepa. This has been truly terrific. We certainly appreciate the time that you've spent with us tonight. As I put into the chat window, you'll also be directed to a brief survey. We're just wanting to make sure that we get your feedback on how things are going with these webinars so we continue to improve. So if you would take a moment just to fill out just a few quick questions for us, we certainly would appreciate it. And we look forward to having you join us another time around. So I will go ahead and stop the recording now. It looks like there are a few more questions, and I'll let others to address those. So thanks, everyone, and have a good night.